The way that number 11 is worded, it's worded in a way such that there's could be more than one answer. It's a select all that apply type answer. Which representations, notice there's an S here, plural, match the equation y equals negative 4x plus 5. So we have to check each one. So the first one, right off the bat, I'm looking at this. This is a negative slope. Lines with a negative slope go down like that. This is increasing. So this is a no. Now the letter B maps 1 onto negative 1. So I'm going to check that. I'm going to plug in a 1 into my equation to see if it works. For negative 4 times 1 is negative 4. Take, so that's a plus 5. Plus 5 is equal to positive 1. So actually, this is the coordinate 1, 1. So 1 actually maps onto positive 1 for this mapping diagram. So this also is a no. But this is kind of promising 1, 1 right here. Okay, we know that this one's true. We have to check the other ones. Let's plug in the point 10 and see if we get 35. So is negative 35, if I substitute that for y, is that equal to negative 4 times 10 plus 5? So negative 4 times 10 is negative 40 plus 5. Is that equal to negative 35? And it turns out that it is, because when you add negatives and positives, you subtract and keep the sign of the greater number. So negative 35 equals negative 35. So yes, this one's good too. Let's check the point 5, negative 15. See if that one works. So we're going to try it by plugging it into the equation, see if it makes a true statement. I'm going to plug in, substitute negative 15 for y. And I'm going to substitute in 5 for x. So negative 4 times 5 plus 5. Negative 4 times 5 is negative 20 plus 5 is negative 15. So negative 15 equals negative 15. This one's correct too. The point 0.05, well, that's our y-intercept, and our y-intercept's 5. So that one's true. So this, letter C, is a yes. Now let's look at this set of ordered pairs. We know that this one's true. We know that this one's true. Let's check the point 2, negative 3, and 3, negative 7, because we have not verified those yet. So I'm going to get my equation, y equals negative 4x plus 5. I'm going to substitute in a 2 for x. So negative 4 times 2 plus 5. I'm going to put in a negative 3 for y. And I'm going to go like this. I'm running out of room here. Negative 4 times 2 is negative 8 plus 5. Is that equal to negative 3? This is negative 3 equals negative 3. So yes, this one is true. So the last point there is to check is because in order for it to, these ordered pairs to represent this equation, every single one has to represent the equation. We know the first three do. So the last one we had to check is the coordinate 3, 7. So we're going to substitute the negative 7 for y. We're going to substitute 3 for x. Negative 3 times, I'm sorry, negative 4 times 3 is negative 12 plus 5 equals negative 7. Negative 12 plus 5 is equal to negative 7. So yes, it does satisfy this equation. It does make this equation a true statement. They are all solutions, so D also is a yes. So A no, B no, C yes, D yes.